Here come the homework answers and what you should have had on your paper. For number 1, you start with the derivative, set it equal to 0, and then find the solutions. And in this case, you come up with x equals 1 and x equals 0 for solutions. If you plug 0 back into the original function, you come back with 0 and 2. That's a critical point. And then you come back with 1. Put 1 in the function, and you come back with 1. So you have 1, 1 that are critical points on this. Now notice when you go back to choose a point on either side here, for the first one it comes back plus plus. Today we're going to look at something that you can do to check even further to find out if it is a maximum or a minimum. And in this case over here you have a 0 that comes back and then a plus for what I put in. So anytime you see something like that that looks a little crazy, you can do this. There is such a thing called the second derivative test, which we'll start using today. And you start with your regular function. You've already found the first derivative, but then you find the second derivative. And you plug in your x value for your critical point. When you do that, you're not interested in -6 or 6, which are the answers. You're only interested in the signs of those answers. For example, when I plugged in 0, the x value of the first critical point, I came back with -6. The only thing we need to know is the sign is negative. If it's negative on the second derivative test, then the point is a maximum. In other words, the opposite. And then I plugged in 1 from the second critical point, the x value, and came back with a +6, which is plus. That means the point is a minimum. And here's number 2, same process. I found x values of x equals 0, x equals the square root of 1/2, and x equals the negative square root of 1/2. Notice you have x squared equals 1/2. You can't just put down the square root of 1/2 because it's plus or minus when you find the square root of something. So you have 3 different things to plug back in. When you plug in the 0 back for the original function, you get back a 6. So you have a critical point of 0, 6. And then if you plug in your -1/2 squared, or not -1/2 squared, but the negative square root of 1/2 and the positive square root of 1/2, you come back with the same answer each time. 5 3/4 and 5 3/4, or 5.75. Now if you go to the test to see if you can find something on either side, to see if it's maximum or minimum, when I do this I come back with a negative and then a positive, which would imply that it is a minimum. That is not the case, because when you look at the graph it doesn't come out that way. And I have the graphs on the photo stream, which I'll show you here in just a second. Now if you do the second derivative test on number 2, your second derivative is 12x squared minus 2. And if you plug in the 0 from that first point, you'll come back with a -2. And negative means that it is a maximum point. The other 2 came out to be minimums, and those were correct. When you choose something on either side of your x value, it does give you a proper reading. Anytime you need to double check, you can use a second derivative test, or in some cases you can use that exclusively. Here comes number 3. On number 3, this one worked out pretty simple because you get just one x value of a -1/3. When you evaluate that, you come back with a -1 1/3. So your critical point is -1/3, -1 1/3, and when you find a value on either side of a -1/3, in this case I chose -2 and +2, you come back with minus plus, and that is a critical point. Remember, you can use your graphing calculator to plug in the equation and get a graphic idea of what the graph should look like. Here's number 4. On this one, again, you get an x value of 2, When you evaluate for that, you get a 4, so it's simply 2, 4. Plugging in on either side of 4, such as or not 4, but 2, plugging in on either side of 2, I used -2 and 4, and came back with an 8 and a -4. That's plus and then minus. That means it is a maximum point. Here comes 5. On this one, when you solve for x after the first derivative is taken, you come back with x equals 0, and then you have x squared equals 3/5. So that has to be x squared is the plus or minus of the square root of 3/5, or 0.6. So you're going to have 3 different points to find. When you plug in 0 for the original function, clearly that comes back to be 0. And that's going to be a point of inflection because it's going to have neither a maximum or a minimum. Now if you plug in the positive square root of 3/5 for the original function, you come back with a negative 0.1859. So there's your point. Square root of 3/5, negative 0.1859. And when you find points on either side of that, it could come back to be minimum, or it does. The only reason this is in blue is to separate it from the orange. And then the same thing, plug in negative square root of 3/5 into the original function and come back with this point. The only difference being it's negative. This one is positive on the x value. Now a second derivative test, look at what happens here. When you plug in -1 and +1, you come back with plus plus, and that's for testing 0. Plus plus means neither minimum or maximum, and that is correct in this case. It is a point of inflection. But when you plug in down here, such as a -1 and a +1, you come back with a square root. Or not a square root, but 2 positive signs. So a second derivative test you might want to check. If you use a second derivative test, you have 20x to the third minus 6x for your second derivative. Plugging in a 0 for your first point, it is a point of inflection. It comes back to be 0. If you plug in the square root of 3/5, you'll get back a positive answer. So it's a minimum. And then plugging in the negative square root of 3/5, you get back a negative answer. That means it's going to be a maximum. Alright, for this one you come back with an x value of 0.375. Plug that back in to get 1.4375. And if you test on either side of that with a -1 and a 2, then you'll get back with minus plus, and that is a minimum. On this one you'll get an x value of 2. When you set the derivative equal to 0, you get back a 2. And plugging that back into the beginning, you get a -16. On either side of 2, you could have a -2 or a 4, and that comes back to be minus plus, so that is a minimum. On this one, take the derivative, set it equal to 0, and you get a -4. Plug that back in up top to get a point of -4, -36. Find values on either side of -4. I chose -6, -2. I get back a minus plus, so that is a minimum. Set the derivative equal to 0. You get a 3/4. Plug it in, and you come back with 1 1/8. Find values on either side of 3/4, and you get a -2 and a 2. So that's plus minus. This should be a maximum point. On this one, when you set the derivative equal to 0, you get 2 values, 0 and 2. When you evaluate for 0, back in the original function, you get back 0. So 0, 0 is a critical point. And for plugging in 2, you get back a -4. So 2, -4 is a critical point. If you look at this one here, the 0, 0 point, and find -1 and 1 on either side of the x value, you get back plus minus, and that one does work out. on this one, you have 2, -4, and I came back with 2 positive values, so I want to check that again. And on the second derivative test, you come back with a second derivative of 6x minus 6. And just to be certain, I plugged in the 0 from the first point and came back with a negative, so that is indeed a maximum point. When you plug in the 2 for the second point, you come back with a positive 6. That means it will be a minimum point. To find and define critical points of a function. Here is an example. F of x equals -2x plus 4x minus 5. Alright, we'll start with a red marker this time. Find the first derivative. And that is going to be a -4x plus 4. And once you find the first derivative, you must set that equal to 0. And solve. Move the 4 to the right and divide -4 by -4 to get an x value of 1. Now we need to plug that back in to the original function. So f of 1 is -2 times 1 squared plus 4 times 1 minus 5. That gives us a -2 plus 4 and then minus 5. That's going to be -2 plus 4 is 2, minus 5 is a -3. So we have a critical point of 1 and -3 to start with. So it's going to be maximum, minimum, or a point of inflection. Now there are such things as global maximum, global minimum, and then local maximum, local minimum. We haven't gotten into that yet. As long as you can identify max or min right now, then you're doing good. Okay, next, after that, we have to determine if this is maximum or minimum. So we're going to pick values on either side of 1. I'm going to choose -1 and 3, and we'll do this on the other side. So we're choosing -1. So remember, you have to use the derivative to evaluate. So -1, that's going to be a -4 times -1 plus 4. Remember, the derivative was -4x plus 4. That's what we're plugging it back into. And that would be 4 plus 4, which is 8. So that is a plus. Now evaluate the first derivative for 3. Remember, we chose -1 and 3 out of thin air, just because they're on either side of the x value of 1. So -4 times 3 plus 4, that's -12 plus 4, which is going to be a -8. So we have plus and minus. What should our point be? Should be what? Maximum. It should be a maximum. If you start with plus and end with minus, it should be a maximum. We can check real quick by using the second derivative test. The second derivative test. Remember, the first derivative was this, a -4x plus 4. And if you find the second derivative on this one, that would end up being simply a -4. That's not going to be much help to you. So on the quadratic equations, set up in the form of ax plus bx plus c. When they're in that form, chances are what you find by plugging in on either side is going to be right. This one won't help you much. You have no x in there to insert something in. So the answer is negative. However, you can still get the right answer from it. That is a negative sign. Therefore, it should be the opposite, which is a max. In this example, f of x is 2x to the 4th minus 6x squared. You must find the first derivative, and that would be 8x to the 3rd minus 12x. Okay, and then set that equal to 0. You can factor out a 4x from that and be left with 2x squared minus 3 equals 0. And from there, set each one of these equal to 0. So 4x equals 0. Clearly, x is 0. And then on the other side, 2x squared minus 3 equals 0. Move the 3 to the right. And you end up with x squared equals 3/2, which of course means x equals plus or minus the square root of 3/2. That means you have 3 critical points. This is 1, and when you break up the plus or minus on the square root of 3/2, you end up with a negative square root of 3/2 and a positive square root of 3/2. So we have 3 different things to check. Now let's plug in 0 to the original function, and that's going to be 2 times 0 to the 4th power minus 6 times 0 to the 2nd power. Clearly that is going to be a 0. So your first critical point is 0, 0. Then go back and plug in the positive square root of 3/2. So you'll have 2 times the square root of 3/2, and that quantity is to the 4th, and then minus 6 times the square root of 3/2, that quantity to the 2nd power. And we come back with negative 4.5, which means that your next critical value is the square root of 3 over 2 and the negative 4.5. Now the last one to check is going to be the negative square root of 3/2. So that would be 2 times the quantity negative square root of 3/2, and that's to the 4th power, minus 6 times the negative square root of 3 over 2, and that quantity is to the 2nd power. And we come back with, again, a negative 4.5. That means your next critical value is negative square root of 3/2, and then negative 4.5. Let's use a second derivative test to figure out max, min, or point of inflection. Now, on this, remember the first derivative was this. It was 8x to the 3rd minus 12x. That means the second derivative is going to be 24x squared minus 12. Now, for a second derivative test, let's plug in the x value from the first point, which is 0. And if I put in 0, 24 times 0 squared minus 12, I come back with a negative 12. Since that is negative, it should be what kind of point? Maximum. Okay, so let's evaluate the second derivative for the square root of 3/2. So that's 24 times the square root of 3/2. Square that quantity and then subtract 12. So I'll come back with 24. There's a positive. That means the point should be what? A minimum. So we have another one to go through. And we'll have the negative square root of 3/2 and insert that into the second derivative. And here we have 24. That one is positive, so this one should be what? A minimum.